Yes, good morning, children. Here, the first numerical we are going to discuss is prove that root 5 is an irrational number. So, first we considered let root 5 be a rational number. Therefore, rational number standard format I taken root 5 is considered as p by q, where p and q are integers and q is not equal to 0. So, by considering this, I did the squaring on both sides. Therefore, root 5 whole square equals p square by q square I written. Once we taken the standard form and squaring on both sides, then square and root I get cancelled. Therefore, 5 equals p square by q square I written. Therefore, I just interchanged the numbers. Q square can be written as p square divided by 5. I called it as equation number 1. Now the three most important considerations you have to understand. First, p square is divisible by 5. Then p is also divisible by 5 I considered. For this example I taken, if perfect square 25 is divisible by 5 means it's a root. 25 root, you remember, it is a 5. 5 is also divisible by 5 only. So, based on this concept, my dear children, okay, so p square is divisible by 5 means p is also divisible by 5. Therefore, 5 is considered as the HCF of p, the most important consideration. Therefore, we called it as p is a prime number. Next, I called p as 5k and substituting p in equation 1, we get q square equals p square by 5 is equation number 1, where p is there I written 5k whole square divided by 5, and 5k whole square gives you 25k square divided by 5. 5 ones are 5 fives are I cancelled. Therefore, remaining is q square equals 5k square, and 5 I shifted to left hand side. From numerator it came to denominator. Therefore, q square by 5 equals k square. Here again the same three steps I will consider. Q square is divisible by 5, then q is divisible by 5. Therefore, 5 is the HCF of q. So once we taken 5 is considered as a prime number. Therefore, P and Q both are having the same common factor 5. Once both the terms are having same common factor 5, this statement contradicts that what we considered root 5 is a rational number. Okay, as the contradiction is arised, we can clearly prove that root 5 is an irrational number, my dear children. Yes, my dears. Next numerical we are going to discuss is prove that 1 divided by root 11 is an irrational number. So as we discussed in the earlier numerical, first I considered let 1 by root 11 be a rational number. Rational number standard form p by q I taken, where p and q are integers. Okay, along with that, what we have to remember the basic concept, where denominator, that is q, is not equal to 0. So after this squaring on both sides I did. So here 1 by root 11 whole square is p square by q square I considered. 1 square is 1, root 11 square is 11 equals p square by q square. Transpose the numbers. Q square into 1 is q square, 11 into p square is 11p square, and when 11 is shifted to left hand side, q square by 11 equals p square. This I considered as equation number 1. And as q square is divisible by 11, q is also divisible by 11. Therefore, 11 is the HCF of q and 11 is a prime number you have to consider. After this, I called q as 11k and I substituted q value in equation number 1. Equation 1 we are having q square by 11 equals p square. So where q is there, I written 11k square, 11k whole square it is, divided by 11 equals p square. And remember, 11 square is 121, k into k is k square divided by 11, and I cancel 11, 1 and 11, 11 is 121, you remember. Therefore, 11 is shifted to left hand, p square by 11 equals k square. Once you got it, children, again the similar steps you have to understand. As p square is divisible by 11, p is also divisible by 11. Therefore, 11 is the HCF of p and 11 is a prime number. So what we proved here, 11 is the HCF of P and 11 is also the HCF of Q. This contradicts that 1 by root 11 is a rational number. As the contradiction is arised, 1 by root 11 is proved as an irrational number. Yes, my dear children, next numerical we are going to discuss is prove that square root of 2 is an irrational number and hence show that 3 minus root 2 is an irrational number. Here, root 2 is an irrational number. How to prove? We already discussed it. Therefore, next one, 3 minus root 2 be a rational number I considered. Therefore, 3 minus root 2 is in the form p by q, that is standard form of the rational number where p and q are integers and q is not equal to 0. Definition you should remember. Then minus root 2 equals p by q plus 3 I shifted to right hand, it became minus 3. As we have shifted here, I took the LCM. Q is the LCM, therefore numerator becomes p minus 3q. Then negative sign I shifted to right, plus p become minus p, minus 3q become plus 3q divided by q. Now observe the left hand and right hand conditions. Left hand is root number which is an irrational number, but right hand is non-root number which is considered as a rational number. And here LHS is not equal to RHS, therefore this contradiction arises that 3 minus root 2 is a rational number, therefore we have proved 3 minus root 2 is an irrational number.